Hi, I'm Bob. We have completed the Consumer Theory section of the Introductory Microeconomics course. Another section of this course is the Producer Theory. In the next few videos, we will look at the production outputs and production costs. We will try to answer the questions of what is the cost of production, how much to produce, and at what price the products are sold. We will analyze the production process in the short run and in the long run. Firms can transform inputs into outputs in many different ways. For example, the ice cream firm employs labor to produce ice cream cones. Labor is the input, and ice cream cones are the output. The various ways that a firm can transform inputs into output are summarized in the production function. The production function is the relationship between the quantities of inputs and the maximum quantity of output that can be produced given current technology and organization. We assume that labor is the only variable in the short run, so we can write the short run production function as Q equals FL. It shows how much output can be produced for each level of the only variable input, labor. We can also write the production function as Q equals F L K bar. Labor and capital are the two inputs, and we assume that capital is fixed in the short run. Labor is the only factor that can change in the short run. The short run production function is also referred to as the total product of labor, the amount of output or total product that a given amount of labor can produce while holding the quantity of other inputs fixed. Let's draw the total product curve. Suppose we observe the amount of ice cream cones produced for each level of labor and have a total product schedule. Here we have the total product table or schedule, and the information helps us plot the total product curve. The total product curve is the graphical representation of this table. On the vertical axis, we have the number of ice cream cones per day, and on the horizontal axis, we have the labor in terms of the number of workers per day. The total product curve shows the relationship between the input labor and the output ice cream. Let's plot points A, B, C, D, and E. They correspond to the table. Point A represents 5 workers per day and 630 ice cream cones that are produced per day. At point B, we have 10 workers per day and they produce 2,010 ice cream cones per day. At point C, we have 15 workers and they produce 3,390 ice cream cones. When the number of workers increases to 20, the total product rises to 4,020. It is point D. Finally, point E represents 25 workers per day and 3,150 ice cream cones produced per day. We connect the points and get the total product curve. We say that the curve is not a straight line. Initially, the total product increases at an increasing rate, as the interval between point A and point B shows. Then, the total product continues to increase as labor increases, but at a decreasing rate. We can see that between point C and point D, The shape of the total product curve depends on the marginal product of labor. The marginal product of labor is the increase in the quantity of output obtained from one additional unit of labor, holding other factors constant. Why is the total product curve not a straight line? Because the marginal product of labor changes as more and more workers are employed. If each worker is equally productive and can produce the same amount of ice cream cones per day, then for every one more worker, the total product should increase by the same amount. It would give a straight line. However, in reality, when the firm employs more and more workers, each new worker's productivity is not the same. That is, the marginal product changes. When there is no worker, the output is 0. When the firm employs 5 workers, the output increases by 630 units. As the firm hires 5 more workers, the output increases by 1,380 units. The marginal product of labor increases from 630 to 1,380. We can calculate the marginal product of labor for each 5 more workers. We can see how the marginal product of labor changes with labor. The marginal product of labor increases at the beginning and then reduces later. The corresponding total product curve increases at an increasing rate at the beginning and then increases at a decreasing rate later. Here are some observations. First, the total product curve shows only the maximum amount of output that can be produced from given levels of labor. That is, the production function includes efficient production process only. Second, this is the short-run total product curve. The only input we can change is the labor. The other inputs, such as capital and land, are held constant. Third, as more and more workers are employed, they produce more and more ice cream cones, but the speed is not constant. So the total product curve is not a straight line. Using more and more workers will eventually lead to very little returns to labor. Fourth, hiring more workers could reduce the total product of ice cream cones, as point E illustrates. It means the level of total product could decrease. It could be due to the limited number of machines they have to share, an extremely crowded working environment, or the difficulty of organizing the workers. There is a level of labor that maximizes the total product. In our example, that is point D, where 20 workers are employed and 4,020 ice cream cones are produced. Thank you for watching this video and subscribing to my YouTube channel. See you next time.